So we are looking at solving trig equations today. We're just going to do simple equations. And I have this equation here, sine x equals 1/2. And we're going to start off by just saying that we're going to find solutions between 0 and 2 pi. So that means once in the circle, we want to find the solution. So we have to think about here. Well, we got sine x equals 1/2. So we're solving for x, which is the angle, right? So we have to think about in your head, where does sine equal 1/2? Or you can look at your unit circle as well. So if we think about sine, though, we have sine, or we have this, right? All students take calculus. And sine is positive in quadrant 1 and 2. So we have two places where sine is going to equal a 1/2. So sine is equal to 1/2 at, if you're using your hand trick, it's equal to a half here. If you're not using that, you probably have these memorized, or you can look at your unit circle. But sine is equal to a half when x, or the angle, is equal to, we're going to do radians here, so pi over 6. So if I think about in quadrant 2 over here, I also need a reference angle here of pi over 6. So what is this angle? Well, it is 5 pi over 6. So since we're just between 0 and 2 pi, we're going to call it, right? Those are our two solutions. Now, if it had said find all solutions. Well, remember, we could keep adding 2 pi to each one of these over and over and over again to get the same reference angle, right? If I had pi over 6, if I added 2 pi to that, I would get 13 pi over 6. 13 pi over 6 has a reference angle of pi over 6, so sine of 13 pi over 6 is the same as sine of pi over 6, which is 1/2. So the thing about these, if it limits us between 0 and 2 pi, we're just going to find those two initial answers. If it does not, then we're going to have to do a little bit more here. And we have to show, we have these two initial solutions, right? Pi over 6 and 5 pi over 6. So we have to show that we could keep getting the same thing if we added 2 pi each time. So we're going to add 2 pi into those. So if it says all solutions, we're always going to add this 2 pi into those answers. And we have to say over to the side that n has to be an integer. So we can write it like this. N is equal to 0, plus or minus 1, plus or minus 2, and just do our dots after that, just to show that we're only talking about integers for n. This would be our answer if it said all solutions. This would be our answer if it said that we wanted to find the solution between 0 and 2 pi. So we're always finding the angle whenever we are solving here. So if we look at number 2, we have 2 cosine x equals 1/2. Now we have to do a little work on this one because I need my cosine x to be by itself. So if I added 1, so we got 2 cosine x equals 1. And then if we divided by 2, we would have cosine x equals 1/2. So if I think about cosine now, where is cosine positive? So we have all students take calculus. Cosine is positive in quadrant 1 and 4. So I'm going to need the two angles. So I need cosine equal to 1/2 here. And I need I need the angle here. So this angle, of course, is pi over 3. So if I need this angle, I'm in quadrant 4, but I need a reference angle of pi over 3. So that would be 5 pi over 3, right? We're almost to 2 pi. So my solutions would be x equals pi over 3 and x equals 5 pi over 3. Now again, if it said find all solutions, this would be if we were between 0 and 2 pi. If it said all solutions, we would have to add. So x is pi over 3 plus 2 pi n, or x is 5 pi over 3 plus 2 pi n, and we need to say that n is an integer. So n is 0 plus or minus 1 plus or minus 2, and so on. So if it says find all solutions, we're going to have this part added on with it. If we're only finding the initial solution in the first circle, or one time around the circle, then we are between 0 and 2 pi. We only have the two answers. All right, so let's look at this one now. We got a little bit of work to do. Notice that we have sine on two sides of our equation. Well, to solve, I need sine to be by itself. So what I'm going to do, I'm going to get the sines together on the same side. And if this is a minus sine x, then to move it over, I would add sine x. And I also need this plus the square root of 2. I need it to be on the opposite side of the equal sign. So I'm going to subtract the square root of 2 on both sides. So sine x plus sine x would be 2 sine x equals, over here, that would cancel out, and we get negative root 2. So if we divide both sides by 2, we get sine x equals negative root 2 over 2. And we're just going to, on this one, find the solution between 0 and 2 pi. So sine is negative in quadrants 3 and 4. So sine is equal to the square root of 2 over 2 at 45 degrees, or pi over 4. So I need a reference angle of pi over 4 here in quadrant 3. And I need a reference angle of pi over 4 here in quadrant 4. So right here in quadrant 3, this would be 5 pi over 4. And in quadrant 4 would be 7 pi over 4. So those are my two solutions. 5 pi over 4 and 7 pi over 4. So get your operation together. We're finding the angle anytime we're solving. Okay, so 18 cosine x minus 7 equals 14 cosine x minus 5. So I need my cosines together on the same side, and I need this number, the minus 7 and the minus 5, those need to be on the opposite side. So I'm going to subtract 14 cosine x from both sides. So I'm going to get 4 cosine x. I'm going to add 7 to this side, so I get 2. So 4 cosine x equals 2. So cosine x equals 1/2. And I'm just going to find the solutions again from 0 to 2 pi. I don't want to do all of them, just 0 to 2 pi. So cosine, we already did this one on the other page. So cosine's equal to 1/2 here and here. Remember, this was pi over 3. And this one down here, with the same reference angle of pi over 3, was 5 pi over 3. So those are my two solutions. X is pi over 3 and 5 pi over 3. So anytime we're solving these equations, these trig equations, we're finding the angle. And these are always going to be ones, or for us, we're always going to do the problems where this ratio that we get here is always going to be found on the unit circle. We're not really going to use the calculator on these. All right, 2 more and then we'll be done. So I have 3 tan squared x minus 1 equals 0. All right, so we're bringing in tan. So to solve this, or to know what angle we're trying to find, we do have to have tan. We have to solve for tan. So I'm going to have to move the 1, divide by the 3, and then, well, let's do that first. So I got tan squared x equals, if I add 1, we get a positive 1, and then divide by the 3, so we get 1/3. Now I have a squared here, right? So the opposite of squaring something is square rooting. So I'm going to square root both sides. So the square root of tan squared is tan x equals, now remember when we square root a fraction, we square root the top. So the square root of 1 is 1, and square root the 3 on the bottom, which we can't do anything with that. So we're leaving it as a square root of 3. So we got to rationalize. So we multiply that as square root of 3 over 3. Which gives us square root of 3 over square root of 3. So we get the square root of 3 over 3. So if we think about tan, and it might be easy if you're using the hand trick to think about tan is when we flip our hand over, right? So I need 1 over the square root of 3. So that is at pi over 6. So x equals pi over 6. Now, because we took the square root of both sides, I almost forget this. We are going to have to put plus or minus, right? Because anytime we take the square root of both sides, we have to put plus or minus. So that means I want everywhere on the circle where where tan is equal to square root of 3 over 3, which are all of these angles that have a reference angle of pi over 6. So I need pi over 6 as my reference angle in all 4 quadrants. And again, we're just doing from 0 to 2 pi here. So we got pi over 6 in quadrant 2, tan would be equal to a negative root 3 over 3 at 5 pi over 6. In quadrant 3, tan would be equal to a positive root 3 over 3 at 7 pi over 6. And in quadrant 4, tan would be equal to a negative root 3 over 3 at 11 pi over 6. So when you get that plus or minus, you're probably going to have 4 solutions. You will have 4 solutions. And again, we're only doing from 0 to 2 pi. All right, let's look at this last one here. We've got a little factoring on this one. So on number 5 here, I was able to take the square root of both sides to get to solve for tan x. But if we look at this one, we got 2 sine x cosine x minus sine x equals 0. So I have to factor here. So if you notice in these two terms, they both have a sine x in common, right? So what I'm going to have to do, I'm going to factor it just like I know how to factor. I'm going to factor out a sine x. So if I factor out a sine x from this pair or this term right here, I'm left with a 2 and a cosine x. If I factor out a sine x here, I'm left with a 1. Remember, when you factor, it doesn't make it a 0 when you divide by something. It makes it a 1. All right, so these are factored as far as we can go. So now we are going to set each factor equal to 0 and solve. So we have sine x equals 0 and 2 cosine x equal, we'll go ahead and move them. Well, sorry, this is minus 1 equals 0. All right, so on this one, cosine x equals 1/2. And on this one, sine x equals 0. So think about sine. Where is sine equal to 0? So sine is equal to 0 here and here, right? Because sine is y, which means we don't move up any. So sine is equal to 0 when x is 0 and when x is pi. Because we're doing between 0 and 2 pi, not including 2 pi. And then this one, we've done this one a few times. So cosine x equals 1/2 when x is pi over 3 and 5 pi over 3. All right, for some of you, this is review. For some of you, this is new. So if you need help, get on during office hours and I would be glad to help you. Or your teacher would be glad to help you.